Explain the video goal and say this will cover the high-level stages of designing, certifying, and producing an aircraft, the main aerodynamic and structural principles, major systems, propulsion, avionics, flight controls, landing gear, manufacturing and assembly concepts, testing and certification, operations and maintenance, and safe learning paths for engineers and aviation professionals. Give a simple definition of an airplane as a heavier-than-air fixed-wing vehicle that generates lift from airflow over wings and uses propulsion and control systems to achieve and sustain controlled flight for passengers, cargo, or special missions. Describe concept and requirements at a high level. Define mission profile, payload and range, cruise speed and altitude, airport and runway constraints, regulatory category, ultralight, light sport, general aviation, transport, redundancy and safety targets, operational environment, commercial, private, cargo, military, and timeline and budget. Emphasize matching configuration to mission rather than a single universal design. Introduce basic aerodynamic principles in plain terms. Explain lift as the result of airflow over an airfoil, the role of wing planform and camber, how angle of attack and airspeed affect lift, and the basics of drag, parasite and induced. Mention stability and control concepts conceptually, center of gravity, neutral point, static and dynamic stability, and how tail surfaces and control surfaces, ailerons, elevators, rudder, create moments to control attitude. Outline airframe and structural considerations without manufacturing steps. Describe primary structures, wing box and spars, fuselage frames and stringers, empennage, control surfaces and hinges, and landing gear attachments. Discuss material choices at a high level, aluminum alloys, composites, titanium steels, and trade-offs in weight, fatigue life, repairability and cost. Explain propulsion choices conceptually. Compare piston reciprocating engines and turboprops for lower speed and regional aircraft, turbofan and turbojet for higher speed transports, and emerging electric or hybrid electric options for short-haul or urban air mobility. Describe the difference between shaft power driving a propeller and jet thrust producing forward force, and the role of fuel, power density and thermal management in propulsion selection. Cover systems integration and overview. Mention fuel systems and tanks, electrical power generation and distribution, hydraulic or electric actuation for controls and landing gear, environmental control systems for pressurization and heating, avionics and flight instruments, navigation and communication suites, and onboard monitoring and health systems. Emphasize system redundancy and fault tolerance required by certification standards. Discuss flight controls and avionics conceptually. Describe mechanical, hydromechanical, and fly-by-wire architectures and how they translate pilot inputs into control surface motion. Explain navigation, autopilot, flight management systems, and sensor fusion, EMU, GPS, air data, that support precise flight and safety features like envelope protection. Outline manufacturing and supply chain at a high level. Explain design phases, conceptual, preliminary, detailed design and drawing release. Describe typical production practices conceptually, modular kit or subassembly production, wing sections, fuselage sections, bonded or riveted structural joints, system installation and harness routing, and final assembly and outfitting in a certified production environment. Mention quality control, supplier qualification, and traceability without procedural detail. Explain testing, verification and certification in general terms. Cover structural testing, static and fatigue, systems testing, ground engine runs, taxi tests, and instrumented flight test programs to validate performance, handling qualities, and safety margins. Describe the regulatory role of certification authorities and standards, for example type certification, production certification, airworthiness directives, and that documented test evidence and compliance demonstrations are required for approval to fly. Cover environmental and economic trade-offs. Talk about fuel efficiency, emissions targets, noise regulations, material recycling, operational cost per seat mile, life cycle cost trade-offs, and how aerodynamic design, weight reduction and propulsion choices affect both environmental impact and economics. Mention human factors and certification for crew and passengers. Describe cockpit ergonomics, visibility, alarm and annunciation design, accessible maintenance points, and passenger cabin safety features. Emphasize that human factors engineering is integral to safe operations and certification. Suggest safe learning paths and resources. Show concept sketches and timeline from mission definition to first flight. Show animated airflow over wing sections, control surface deflections and center of gravity overlays. Show labeled cutaways of structural members, fuel tanks, and system routing, electrical, hydraulic, fuel, in a non-show comparative visuals for different propulsion types and a concept animation for hybrid or electric propulsion. Show footage of subassembly production, jigging and final assembly in a factory setting, explanatory only, and instrumented flight test clips with data overlays. Show diagrams of certification steps and inspection checklists and end with a note about formal training paths. Use this full script as the video input for Pictory.ai to generate an educational explainer about the process of designing, certifying, and bringing an airplane into service while emphasizing safety, regulation, and professional practice.